Hi and Assalamualaikum warahmatullahi taala wabarakatuh. Today, our team will discussing about the recently accident that was happened involving an industrial truck that carrying sulfuric acid. This accident has causes the sulfuric acid to spill into the nearby lake and contaminated the water in the lake. As we know, the contamination of the sulfuric acid into the lake has causes the water in the lake to drop and becoming acidic. This acidic water uh, is not suitable for the aquatic organisms and plants in the lake. Next.
So we move on to the next slide. So as we know, for the general solution to this accident, and as we all know, an acid spillage is going to alter the pH value of the lake to become more acidic. Therefore, the best way to overcome this accident is to pour a base solution into the lake. Hence, the lake will be neutralized. So, for the next point, the usage of neutralization concepts. So, neutralization can be an effective approach to mitigate the impact of an acid spillage in a lake. The neutralizing agent reacts with the acid, resulting in the formation of less harmful compound and reducing the acidity of the water. However, it is important to consider the potential environmental consequences and involve an appropriate, authorized, or experts in handling and neutralizing the spill to ensure safety and minimize further damage.
As we all know, an acidic lake is very dangerous for the ecosystem. Therefore, the lake must be neutralized. We have decided to use limestone, which is calcium carbonate, as the base. Limestone is chosen because of two main ideas. First one, it is easy to obtain, and the second one, that limestone is very cheap. The process of neutralizing an acidic lake using limestone is called liming. The acid will react with limestone to produce salt, carbon dioxide, and water. In addition, the carbon dioxide produced will benefit the trees and algae around the area, as it will be absorbed to produce oxygen gas through photosynthesis. Hence, limestone is the best base to be used.
So welcome to the data analysis part of the experiment. In this part of the presentation, we have three main objectives. Our first one is to find the concentration of sulfuric acid. The other one is to find the amount of sulfuric acid moles inside the lake. And the next one is to determine how much of the base we will need to neutralize the acid inside the lake. So from our titration experiment, we concluded our sulfuric acid had a concentration of 0.91 mole per liter. And for our alternative, we decided to use calcium carbonate instead of calcium oxide.
So now we want to determine how much moles in the H2SO4 molecules in the lake. So first of all, we know that the value of the lake is 8.67 times 10 to the power of 14 inch cube. So we need to convert it into cm cube. So we will get this value and we will convert it into liter. So we will have 1.42 times 10 to the power of 13 liter. Next, we need to use this formula since we have concentration of acid and the volume of acid in the lake. So we need to substitute the value in the equation and we will get 1.293 times 10 to the power of 13 mole. Next. So here is the equation. You can see right here. The mole ratio of each substances is 1/1. Okay, right now we have mole of CaCO3, which is 1.293 times 10 to the power of 13 mole, and we need to multiply it with molar mass of calcium carbonate, which is 100.0869 G over mole, and we will get 1.2944 times 10 to the power of 15 grams, or equals to 1.294 times 10 to the power of 13 kilograms.
After this, the next part of the data analysis includes finding the leftover produced carbon dioxide in the lake and the leftover salt in the lake, which is calcium sulfate. And so the reaction between the calcium carbonate and the sulfuric acid produce carbon dioxide inside a gaseous state, and the reaction produces a calcium sulfate in solid state. Next. Next slide, please.
So here is the solid calculation how we could find the value. So first of all, the mole of CO2 that produced is 1.293 times 10 to the power of 30 mole. We need to multiply it with 24 liter per mole, which we will get 3.1032 times 10 to the power of 40 liter. And next, we need to calculate for leftover salt. So the mole is the same, and we need to multiply it with molar mass of CaSO4, which is 136.14 gram per mole, and we will get 1.76 times 10 to the power of 15 grams, or equals to 1.76 times 10 to the power of 12 kilograms.
That will conclude the data analysis part of the experiment. Thank you.
So to conclude the case study, it revealed that the lake contained a significant amount of sulfuric acid, totaling to 1.293 times 10 to the power of 30 mole, which was neutralized by using 1.294 times 10 to the power of 12 kilogram of calcium carbonate. During the neutralization reaction, 3.1032 times 10 to the power of 14 liters of CO2 and 1.76 times to the 10 power of 12 kilogram of calcium sulfate were produced. So in the end, the lake was safe for the environment.